All right, take it away.
Hi everyone, I'm Ali Balkis and I represent SythLett Cells. It's easy to be jaded by new battery news. Scientists tinker with chemical formulas using all manner of exotic materials only for that research to be faded into the dusty annals of academia. But this breakthrough is different. At SythLett Cells, we have crafted a new battery that comes with a way to be scaled up in the real world. This powerful battery utilizes an innovative, non-flammable, safe electrolyte combined with a lightweight and flexible lithium metal electrode. This erases the safety concerns, for example, flammability and excess weight issues associated with today's ubiquitous lithium-ion batteries. In these present times, we are witnessing an increase of carbon emissions, conflict, natural disasters, and population growth. As of this, our batteries are of prime importance for cutting-edge aerospace applications like UAVs and drones, where they can be efficiently be used for search and rescue operations, military and civilian applications. At SythLett Cells, we fabricate and sell lightweight, non-flammable, flexible batteries for various sectors in the aviation industry, which helps them transition to all electric. The aviation industry will benefit from the robustness, lightweight, and safety of our batteries. Our primary beachhead market is the aircraft battery market based in Australia. For example, batteries powering UAVs and onboard electronics for commercial passenger aircraft. As of 2020, the aircraft battery market opportunity in the Asia-Pacific region was 18 million Australian dollars. Due to the large size and vastness of Australia, and because it relies heavily on fossil fuels, However, this is set to decline slow but steadily by 2030 by penetration of abundant resources, urgency for electrification, and supportive government policies. At SythLett Cells, our batteries are 50% lighter, flexible, and more flexible compared to lithium-ion batteries. This in turn accelerates electrification. From this, our batteries are uniquely well positioned for various sectors in the aviation industry, where lithium-ion batteries are just too heavy, for example, 20 times heavier than kerosene, and that our batteries, due to the flexibility, can fit anywhere along the aircraft, providing enhanced performance and radical aircraft designs. Our batteries are lighter, safer, longer lasting, flexible, and more cheaper than lithium-ion batteries. As a demonstration, we have our novel battery powering a drone, where the weight of our battery is 50% lighter than the original lithium-ion battery and utilizes a non-flammable electrolyte. We evenly interviewed the Australian military, UAV operators, and other end users based in Australia. We wanted to learn what the end user expects from our battery. For example, the speed of charge, the cheapness, and also the longevity. After thorough discussions, we have learned that more powerful, flexible, lightweight, and more cheap batteries are needed. We are aiming to target 3% of our beachhead market, which is nearly 3 aviation manufacturing companies. We expect a profit of 206,400 Australian dollars per year. Our key drivers are the market, as in the customers, cost to make the product, and the net price to sell the product. Drone logistics have such a massive sustainability impact because they are instantly electrified. They can run less. Their costs are, they can run less compared to electric vehicles and have more efficient routing, hence lowering the carbon emissions drastically. To be able to do this brilliant project, we are a bewildering team of 2, myself and Hiroyuki, which we aim to mitigate global warming by our battery solution, realize a more electrified world, produce powerful, lightweight, safe, and flexible batteries, and most importantly, to connect and liaise with various aerospace companies to expose the potential of our batteries. Thank you very much.
Oh, there was nothing bewildering about that. That was fantastic. So I know that there is going to be, Sarah's going to have questions, Simon's going to have questions. Are we going to go to you first, Sarah?
Yes.
Yeah.
Thanks, Ali. Can you talk a bit about the manufacturing of the batteries? What are your plans there?
So we use a robotic stacker, it's called a Z stacker, in a argon-filled glove box.
Can you say that again in English? And also, how much does it cost? Would you do it locally? Just talk about the manufacturing in general.
Yeah, so we have a prototype pouch cell facility over in, it's called Battery Hub over in Burwood. We use robotics to get the anode and the cathode, and then we use so the robot gets the anode and the cathode and gets the separator and just stacks the cells together. And then afterwards we'll get that, and then we'll do the electrolyte filling in the glove box as well, and then we do the side sealings and seal it off, and then we've got the pouch cell.
Okay, so one quick follow-on. Yep. So that's the battery, and then obviously before any manufacturer uses it, it has to be tested and audited, approved, and so forth. So can you talk about that?
Yes, definitely. So once we filled in the electrolyte, we will do something called formation cycling on the battery cyclers, and after we do, so usually that's 5 cycles at C over 20, which is 20 hours to charge and discharge. And then afterwards, we would do a triple CV charge, and then our batteries are ready to be, sold or used.
Have you got a patent for the
Yeah,
technology?
we have a patent for the electrolyte. Yep.
Thanks, Ali. Congrats. So you've picked a very narrow use for the batteries in the presentation that you've shown us. Is it something about your battery that is particularly suited to aerospace sector or other lithium ion?
Not at all. It can go beyond.
Right.
It can go to EVs, electric bikes, everything. It can fit in anything. So because it's a pouch cell, the size versatility is it's great. So we can create any shape or size, and that can fit into many applications, not just for.
And is it already? You said it. Did you say it was half the price?
30% cheaper than lithium-ion batteries.
Cheaper, yeah. And so is that based on your current? Like, how much scale do you have to get to achieve that lower price?
So we can get to 1.5 amp hour, if that makes any sense.
No, I mean,
the capacity of the battery.
How many units do you have to get to be able to deliver into a large market at that lower price?
It's much larger, obviously, but just because we're doing everything in this prototyping facility, we're able to slowly chip away, and we haven't really thought about it, to be honest. But
right.
But I think it will definitely,
Okay.
So
thank you very much.
No worries. Thanks.
Thank you. So while the judges